We've learned the Aldol reaction and the alkylation reaction. They both have very similar starting materials, right? There's some sort of carbonyl. With the alkylation, what we want to do is we want to add a strong base such as LDA or sodium hydride, and then add some kind of other electrophile, right? Some other RX. And in that case, we'll get alkylation. And then what we just learned is the aldol here. Here we just add some sodium hydroxide and some heat. And instead here we get the aldol condensation reaction. So think about the similarities and differences between these reactions. In both of them, our carbonyl is going to act as the electrophile in its enolate form, or my bad, as the nucleophile, not the electrophile. And then it just depends which electrophile it's going to react with. On the alkylation, we have some alkyl halide. On the condensation, we just have it reacting with a molecule of itself, right? So if you think about the left side, in step one, we have a strong base to form the enolate only. So we take all of our carbonyl and transform it into the enolate. When we do that, we have no leftover carbonyl to act as the electrophile. And so it won't react with itself because they're all enolate. There is no carbonyl anymore. And then in step two, we add the electrophile. Contrast that with that on the right. We have a weaker base, right? Just our hydroxide. And so the enolate, which acts as the nucleophile, and the carbonyl, which acts as the electrophile, are going to be present at the same time. And so they're going to react with one another. Also notice there's no other electrophile present, right? So once you make the enolate, it has no other electrophile to attack other than the carbonyl.